Hello everyone, in this video we're going to go through quicksort. Quicksort is the third sorting algorithm that we cover here, and it's the best algorithm or the quickest algorithm, hence the name. But the problem with quicksort is that it's a little bit more complicated to understand or reason about when we try and implement it in our programs. So for example, if you had to code a solution in bubble sort or even insertion sort, it would be much easier to create the code, while in quicksort it's much more difficult. And one of the main reasons for this is because quicksort is called a recursive algorithm. And if you don't know, a recursive algorithm is an algorithm or a function that calls itself within the function. So it means from a complexity point of view, it's very time efficient as far as the computer is concerned, but it's not as easy for us to understand as humans. So I'm going to create an example and we're going to jump into it. So for this example, I'm just going to pick the numbers 8, 5, 18, 20, 2, and 9. So this is the array that we're going to work with. This is the array that we want to sort. So the first thing we need to do is pick a pivot. So the idea of a pivot in quicksort is it's just a number, but that number will be our pivot or our midpoint value, and all the elements to the right of our pivot will be greater, and all the pivots to the left of that number will be smaller. So for example, if we picked a number like 9, we would go through all these elements here in the array and we would put them all either to the left or to the right of 9, depending on what number they are. Now, you might think, how do you pick the pivot? And it doesn't really matter to a certain extent on what number you pick as the pivot. You could pick like the number 18, but in most cases, for simplicity, we usually choose our pivot being either the first number or the last number. So you can do either or. Now in this example, we're going to continue with selecting the last number, which is 9. So when you've got your array, pick your pivot, let's say 9, and we're going to put 9 down here. We're going to put a little box around it because we know this now is our pivot that we have selected. And now we need to go through the rest of the array. So we need to go and look at 8. Now we can see that 8 is smaller than 9. So we select our first number, which is 8. 8 is less than 9, so we would put it on the left hand side, which is here. Then we'd move on to 5. 5 is also less than 9, so we would put it on the left hand side also. Then we come to 18. Now 18 is greater than 9, so it would go on the right hand side. So we put 18 here. Then we move on to the number 20. 20 again is bigger than 9, so it would go on the right hand side. And then finally we've got the number 2. So 2 is obviously smaller than 9, so it will go here on the left hand side. Now by looking at this, you might think this isn't sorted, which it's not, but part of this array is sorted. So for example, the number we picked, which is 9 being our pivot, everything to the right of 9 is correct. Everything to the right of 9 is bigger than 9. And you can see this by the numbers 18 and 20. Now, these numbers might be, mixed up. It just so happens that these are in the correct order. When we look at the left hand side, we can see that all these numbers here are also correct in terms of they're all less than our pivot, which is 9. But if you look closely at them, you can see that they're not ordered, and in fact they're actually totally unordered. They should be the other way around. But you can see with this example that all the numbers on the left are indeed less than 9, but there's no guarantee that they're sorted or that they're in order. So we need to go through another iteration of this algorithm. And next we pick 2 more pivots. And again, we're going to keep going with the standard of taking our last elements. So you could imagine these numbers here as being their own separate array, and you could imagine these two numbers here as being in their own separate array. So we're going to pick the last number for each. So 20 will be our pivot in this case, and we can put a box around it. And 2 is going to be our pivot in this case, and we can put a box around 2. Now we need to go and iterate through our sub-arrays. So we can see by looking at this, we know that 8 is greater than 2. So 8 would go here. And we know that 5 is also greater than 2. So 5 would go here. Now for 18, we know that this is less than 20. So we would put it in here. Now again, you can see if we look at this array, it's sorted in terms of our number that we've picked, our pivot, which is 20. The numbers to the left and to the right of this are correct. Now there's no numbers to the right of this pivot, but there is one number to the left and it's in order. Now it was in order before, but now we definitely know that it's in order. Now if we move on to our next array here, we can see our 3 elements and our pivot here is 2, and the two numbers, both 8 and 5, are correct as far as saying that they're in the right position because they're to the right of the number 2. But again, these numbers themselves are not sorted, and we need to keep going down layer by layer until we only have one element left. So for example, here on the right hand side you can see that there was only one element here, which was 18. So we know that this part of the array here, we could say that this part here is sorted. This gets a tick. But this one here is still unsure. Now this could be sorted, but we don't know fully yet, and we won't know until we get to only one single element. So we're going to continue with this then by picking our pivot. So our pivot is just going to be between 5 and 8, so our pivot will be 5 here, and then we go and check to see our number. Again, this is our last number, so once we've done this, we know that the array is sorted. So we look at this and we see, yeah, okay, 8 is greater than 5, so 8 would go to the right, and we can just bring all this stuff down here just to check our answers. So we bring down 18 and we bring down 20. So do you remember that I said this was a recursive algorithm? So meaning the function calls itself. So with this, there's a function call at each of these layers. And I'm going to just split these up into layers to allow you to visualize the problem a little bit better. So you can imagine this here as our first layer. So we'll call this number 1. And in this first layer, we picked our pivot as 9, and we placed our elements to the right and left depending on what number they were. Now in this here, you can imagine this as our second step. So in our second step, we were splitting our array again, but in this case, we had 2 different pivots, and these 2 different pivots dealt with 2 different subarrays of numbers. And then finally, our third function call here, we only had to pick one pivot for this, which was 5, and then we put 8 to the right of that. And we'll just fill that in. So now that we've performed 3 different steps, you can think of it as us going 3 layers deep. So when we go 3 layers deep, we have to go back up. So when we go back up the layers, we know for sure that whatever order we have our elements in, they will be sorted. So for example, when I take 5 as my pivot and I bring this up here, I know that this is sorted. So I would get a result like this, 5 and 8, and that's what I would pass up. And once I've passed this, we can forget about this layer and we only want to focus on these 2. So on this one, we seen that 2 was our pivot and everything to the right of that was bigger. So we know that 2 goes here. And then we also have our second pivot here, which is 20. So 20 will go here. And then we know that 18 is to the left of it. So we place 18 here. And now we can put an X here because we've completed our work here. And now we're going to go to the first call that we made. And that just deals with our pivot of 9. And we remember that 9, everything to the left and to the right of it. So we put 9 in the middle here. And now if we go and check this, we can see that it goes from 2, 5, 8, 9, 18, 20. And this array is now sorted. Now, as I said at the beginning of the video, this is a little bit more complicated than insertion sort and bubble sort, but it's much more efficient. And if you want to find out more about how efficient it is, or how efficiency and complexity work, I'd suggest to check out our complexity analysis videos.